Guys, how are you? Today we're going to talk about the fact that cosine I is approximately 1.53. So, prove it, we're going to start by the Euler's formula. Here we have it, and the Euler's formula is something really important. If you don't know what I'm talking, I strongly suggest you go learn about it. It's really interesting. So, then we just apply x as being I. So we have this. We obviously have that this multiplication here is equal e to the I squared because I times I, and as the definition, we know that I squared equals minus 1. So we got that I to the minus 1 is equals to cosine I. Then we're gonna have to remember the fundamental trigonometric equation, which states sine squared of x plus cosine squared of x equals 1. Then we're going to manipulate it, and that lands us with sine I equals root of 1 minus cosine squared I. So if we substitute it in our equation, we have it. So then we're gonna disinvolve this equation. We firstly pass cosine I to the other side with a subtract, and then we divide both sides by I, landing us with. Then we're gonna square the both sides of the equation. Applying the definition of I, we have that I squared here in the divisor gonna be 1 minus 1, sorry. And then we put the minus up to this equation. Then we're gonna distribute this square using a plus b squared equals a squared plus 2ab plus b squared. That's gonna be the equation with the square distribution. And if we distribute this minus sign, we're gonna have it. So we can see that cosine square is repeated in the both sides. So we can just cut them off. And then we have this equation. And as we can see, it's just a simple first degree equation, which we can just put cosine I in one side, it put the other stuff that there is in the equation in the other, and we're gonna have an answer. And then by just doing some algebra, passing the stuff to the other side, putting cosine I in one side, we have this. That's the exact value of cosine I. But if you plug approximated values of E on a calculator, you're gonna have that 1.53 approximately. That's it. Thanks for watching the video.